Insertion sort is a simple and intuitive sorting algorithm that works by dividing the array into a sorted and unsorted part. It repeatedly picks an element from the unsorted part and inserts into the correct position in the sorted part. So we have an example, which is the initial array is 3, 5, 8, 6, 2. Step 1. The current element is 5. So compare mo ang 5 sa 3. So which is 5 is greater than 3. So the 3 is in the right position. So no need mo na siya ibalhin. So step 2 ang current element natin is 8. So 8 atras pa siya. Let's see. So 8 is greater than 5. So again, kaya hindi natin na-swap ang 5 sa 3. So it does mean hindi po natin pwede maatras ang 8 sa 5. Step 3. Our current element is 6. Our current element is 6. Compare mo ang 6 sa 8. Pwede ba siya? So, syempre pwede. Okay? Mas tako. So, pwede natin siya i-shift. To the right. So, again, copy the first. So, 3, 5, and shift natin ang 8. So, swapping lang yapon siya. 6, 8, 2. So, ang ating array is 3, 5, 6, 8, 2. Ang step 4 is our current element is 2 at the index of 4. I-compare na naman ang 2. Makapalit ba siya? Yes, of course. So, sulat na. 3, 5, 6, 2, 8. So, ang 2 ba? Ma-shift na ito sa 6? Yes, kaya mas nubo siya. 3, 5, 2, 6, 8. Again. Ma-shift. Siyempre, mas nubo. 3, 2, 5, 6, 8. And again, mas nubo ang 2 kaysa sa 3. So, pwede natin siya ma-shift. So, ang pinakauna is ang 2. So, 3, 5, 6, 7, 8. The right position. Let's talk about merge sort. Merge sort is a divide and conquer sorting algorithm. It works by dividing the array into smaller sub-arrays, sorting those sub-arrays, and then merging them back together in sorted orders. For example, we have a given problem which is 3, 5, 8, 6, 2, 1. 6 to 1. So, it has 6 numbers. So, mag-merge ta, i-divide ta sila kung pila sila kabilog. So, pila sila kabilog? 6 sila. So, ito nga ata sila sa dalawa, which is the left and right. So, ang nasa left kay ang 3, 5, 8. Tas ang sa right kay 6 to 1. So, i-split ta sila or ihiwala yon. Tas kanina 3, 5, 8, and 6 to 1. So, diri na 3, 5, 8 ang tawag is L1 or left 1. Ang diri naman is right 1. So, after natin sila ma-merge sa babaw, mag-add to naman ta sa dalong, which is pwede natin sila tungaon sa 3 or 3, 5 or Unsa sila tungaon sa 3, 5, 3, and 1, 8. Depende kung ano. So, ang akong yung pagtunga is 3, 5, 8. Same here. So, pagtunga na to, pag na-split na nato, ang tawag dara is L. L2, left 2. Ang sa 8 naman is right 2. So, pag na-sort ka na sila, pag na-split ka na sila, pag abot sa dalong, another splitting, which is 3 and 5. And 3 and 5. And then, ang 8, i-bring down na lang na siya sa karon. I-bring down na lang na siya karon. So, ang aton nga sa dalong nag-split, which is the 3 and 5, which is kay L2 siya ganina sa taas, L3 na siya sa baba, because left, right, and right 3. Kinaaman siya sa right, no? So, after na to, i-indicate na to siya. So, ang L3 is 3. Tapos, ang right 3 is 5. Tapos, ang right 2, which is katong 8 sa taas, kaya wala naman siya sang pwede i-split, which is i-bring down ta na lang. Or 2 equals 8. So, ang CMS ta, or code merge sort, is ang L3 and R8. Depende. Tapos ang sundanay na is nasa value. Nakadepende sa value. So, same yapon ang process dire sa right. So, ang sa right kay 6 to 1, same process. So, after na to na ma-merge on dire and nakuha na to ang CMS o ang atong magbalik naman ta sa dire. Which is na i-merge mo naman siya. Which is ang sa left is 3, 5, 8. Dire. Tapos ang sa atong right kay 1, 2, 6. Tapos after na to na ma-merge, depende na siya dire lang. Ang atong merge dire is dire na to kuhaon. Dire. Kani sila. Pero dapat ang pagsunod is ang value or ang value, which is diba 261 ang nauna dire, pero pag-awat dire kay 126 kay depende sa value. So after na to i-merge na nato sila. Tapos ang pag-merge na to is atong depende sa value or sundanay. So ang atong merge is 1, 2, 3, 4, 6, 8. Kay bawal na siya mag-random kay jud na siya.
Heap sort is an efficient comparison-based sorting algorithm that uses binary heap data structure to sort elements. But first, let's heap sort. So before we do that, let's build a max heap. So this is the max heap. So the max heap is rearrange the array into a max heap where the largest element is at the root. So our max heap is 10, 5, 3, 4, 1. By the way, this is our given problem. This one. You can paste it in here. So let's extract the elements from the heap. So how we do that? Swap the root largest element with the last element in the heap. So reduce the size of the heap by 1 and heapify the root again to maintain the max heap property. Let's all repeat this process until the heap size becomes 1. So this is our problem. So let's swap the 10 and 1 and then happify. So it will like this: 5, 3, 4, 1, 10. Oh no, sorry. 5, 1, 10. And then again, let's swap 5 into 1. So, and then let's happify again. 4, 1, 3, 5, 10. That's how you do it. And then again, let's repeat it. So let's swap 4 and 1. Then let's happify again. So the 4 will be in here. So the first will be the 3, 1, 4, 5, 10. 5, 10. So again, let's swap 3 and 1. So it's gonna be 1, 3, 4, 5, 10. Then the sorted way is this one. Sorted way. Sorted. And this is the heap sort. So let's talk about heap sort. So heap sort is, we have a given. So heap sort is an efficient comparison-based sorting algorithm that uses a binary heap data structure to sort elements. So first, let's step in the heap sort. So first, we're gonna build a max heap. This is the given number. So how we do that is we arrange the array into a max heap for the largest element at the root. So let's build up. So we already write the max heap. So it's 10, 5, 3, 4, 1. Then let's extract from the heap. So how can we extract elements from the heap? So let's swap the root or the largest element with the last element in the heap, which is here. So reduce the size of the heap by 1 and happify the root again to maintain the max heap property. Repeat this process until the heap size becomes 1. So our array or problem is 4, 10, 3, 5, 1. So let's extract the largest. So what's the largest is this one, 10. So after we heapify, let's say heapify, we already heapified this one. So the large 10 goes to here because it is the max or the heavier number or the root, which is this one. And now that after we heapify this, 10 is already in this side. So after nato ana, what's the next number na largest to anybody in here? So the next number na heavy or the larger or the sunod is this one. So ano ang atong iswap dira? Syempre, the most lighter, this one. So iswap naman nato sila para happify. Iswap naman sila. So after nato maswap, Ang swap na to is naadto dire. Okay, about the Radix sort. A Radix sort is a non-comparative sorting algorithm that works by sorting the numbers digit by digit. So starting from the least significant digits, we're first place to the most significant digits to the 100 or 3 digits. So here's our given problem. So step 1, find the maximum value. So the maximum value is 802. So the maximum number is 802, which has 3 digits. This determines the number of passes required. 1 4-digit place first, 10, and 100. So let's sort the first place. So number with 0. So number with 0 is 172 and 90. And then number with 2. The number with 2 is 802 and 2. And the next is number with 4. Number with 4. 24. And the number with 5. The number with 5, which is the 45 and 75. Number with 6. 66. And number with, and that's it, it's complete. 170, 90, 802, 24, 45, 75, and 66. So the resemble the array based on that based on these groups is 170, 90, 802, 24, 45, 75, and 66. This is the first place. This is the first. So let's move to the next. Let's move to the 10th place. Let's make this one. And the next is, so let's tap this. So number starts with 0, which is 802. Since wala na siya, so dili siya mabutang sa number with 0. So next is number with 2. So mag-base naman ta sa banga. Okay, ganina nag-base ta sa box sa second digit. So karon mag-base naman ta sa first digit. So, number with 3 is 24. And then, and number with 4 45, and number with 5, oh no, number with 6, number with 6. So number with 6 is 66, and number with 7, 170, 75. And then numbers with 9, so that is the array based on this group is 3, 2, 24, 45, 66, 170, excuse me, 75, and 90. This is the 10. So finally, let's focus on the most significant digit, which is the 100. So then let's do this. Let's just focus on the significant signs. So number with 0, number with 1, number with 8. These are the three significant signs. So number with 0 is 2, 24, 45, 66, 75, 24, 66, number with 170, and number with 2, so 100s is 4, 24, 25, 66, 75, 170, 802. And the final sorted is 2. So the final sorted is final sorted is 2, 1, 4, 45, 66, 75, this one, 173, and 8. So let's start counting sort algorithm. Counting sort is a non-comparative sorting algorithm that sorts integers by counting the occurrences of each element in the array. It uses an accelerated array to store the counts and calculates the sorted positions of the elements. So how counting sorts work? So we have 3 ways, 3 steps, which is count frequencies, calculate cumulative counts, and sort elements. So another example now, which is 4228331, and the maximum value is 8, determines the size of the count array. So first step is count frequencies. Create an count array of size max value plus 1. So initial count array is 0, 0, 0, 0. So each 0 plus 9 plus 1, so equals 9. So let's count the occurs of each element. So for 4, increment count 4 is 0, 0, 0, 1, 0, 0. So for 2, pa-count naman ta sa increment. So, 0, 0, 1, 0, 1, 0, 0, 0. For 2, increment count 2 is 0, 0, then 2, then 0, 1. For 8, increment count 8 is 0, 0, 2, 0, 0, 0, 0, 0. So, dito siya mag-increment. Dito siya mag-another 1 sa 8. So, for 3, count 3 is 0, 0, 3, 2, 2, 1, 0. And then, i-repeat mo lang na siya hasta makuha mo ang final count array, which is 0, 1, 2, 2, 1, 0, 0, 0, 1. So, step 2, compute cumulative count. So, transform the count array into cumulative count. So, count 1 plus equals count 0 is 0, 1, 2, 2, 1, 0, 0, 1. So, again, iulit-ulit mo lang siya like kung ano ang ginamit mo sa taas, amo lang pero na-adjustment lang based on sa number of counts. So, ang final cumulative array is 0, 1, 3, 5, 6, 6, 6, 6, 7. So, isa na lang ka 0 na bilan. So, next step is place elements in resorted order. So, iterate through the input order in reverse order and place elements into their correct position in the sorted array using the cumulative count. So, for 1, place at count 1. So, minus 1 equals 0. Decrement count. So, sorted array is 1, 0, 0, 0. Okay, so for this count ra siya 1. So, ang 1, dito ra siya mabutang sa tubangan. So, ang updated the count array is 0, 0, 3, 5, 6, 6, 6, 6. So, okay, same hapon ang way dira pero na-i-adjustin. So, kung ano ang i-adjust mo dito, muna niya to. So, ang final sorted array is 1, 2, 2, 3, 3, 4, 8.